Hello friends, welcome to Input Output Canvas. So today we'll discuss about a very important coding question. This question is not only important for Accenture coding test, this question is also important for your other competitive exam, other on-campus and off-campus examination. And this question is also important for your technical interview round, because sometimes in the technical interview round the interviewer may ask you to write the code, and these types of question sometimes asked in the technical round. Okay, so before starting the video, make sure you have subscribed the channel, and if you find this video helpful watching the whole video, please like the video. Okay, so let's start the video. So here's the question: the maximum length subarray having equal number of zeros and 1. Okay, so given an array of size n, so you will be given an array of size n and it contains only zeros and 1 in it. Okay, so you have to find the maximum length of subarray where there are equal number of zeros and 1 is present. Okay, so you will be given an input like this, and this is an input array of size n, that is the size 5. Here the size is 5. So what you have to do, you have to find the maximum length subarray where equal number of 0 and 1 is present. So let's say for the first three numbers. So for the first three number, the number of zeros is 2 and the number of 1 is 1. So this is not equal number of 0 and 1. So if you see for the next two number, that is 0 and 1, so here you can see the equal number of 0 and 1 is present. Okay, so similarly for these two number also equal number of 0 and 1 is present. Okay, so for these two number also equal number of 0 and 1 is present, but we cannot output this because we have to find the maximum length subarray where the equal number of 0 and 1 is present. So this is not the maximum length. So the maximum length for this array is this subarray. So here you can see the number of 0 is 2 and the number of 1 is 2. Okay, so this is the maximum length subarray where equal number of 0 and 1 is present, and the length of this subarray is 4. So we have to return 4. So our output is 4. Okay friends, hope you understand this question. Now we will solve this question using map. Okay, first let me tell you what is map. So map is a container where you can store the key and the values. Okay, suppose the key is 1 and for this key it contains suppose 12. Okay, and the next key is suppose 2 and for this key it contains suppose 16, and the next key is suppose 3 and for this key it contains suppose 20. So in this way we can store the key and the value into a map, and it will be very easy to find the value using this key. Okay, so that's why we will be use map concept here. Okay, so I have write the code here and I will explain you in a very simple way. So we have a map. Suppose the name of the map is MP. Okay, and we have initialized sum as 0 and result as 0, and map of 0 equals to -1. So in the map, in the key position of 0, the value of the map is -1. So we have initialized these three. Okay, so next we'll write a for loop for iterating the array. So suppose our array is 0, 0, 1, 0 and 1. So this is our array. Okay, so this is our array, and we'll iterate from I equals to 0 to I less than n. So n is the length of this array. So here the length of this array is 5, as there are 5 elements are present in this array. Okay, so we will iterate from 0 to less than n, and every time we will increase I by +1. Okay, so next what we have done here, okay, let's forget this part. So first we have check. So array of I, that means array of 0. So I equals to 0 for the first time. So array of 0 equals to 1. So if this is 1, then we will return 1, otherwise we will return -1. Okay, so if it returns 1 or -1, and that value will store into this sum. So either this 1 or -1 will be stored into this sum, and every time we will store that value into the sum. and the previous value of the sum will be added. We have write sum plus equals to. Okay, so now we'll check a condition. If mp dot find sum not equals to mp dot end. So what does it mean? So find is the name of a function. So find is a name of a function which is included in the map header file. Okay, so this find is included in the map header file. So inside this find you have to pass a key value. Okay, so inside this find function you have to pass a key value. So this find function will check if this key value is present inside this map or not. So for that we will write here mp dot, because this key value is present inside this map mp or not. Okay, so that's why we have write here mp dot find of sum, and here you can see not equals to mp dot end. So it will search until the map becomes end. So not equals to mp dot end means until the map becomes end it will find, and if the key is find, then what we'll do, we'll do a operation, that is the maximum of result. So here you can see we have initialized the result as 0, so it will check the maximum result and I minus mp of sum. Okay, so the maximum value will be stored into the result, else the I value will be stored into the mp of sum. So I value means this I value, so this I value will be stored into the mp of sum. Okay, so hope you understand this. So let's try run this problem by using this example, and it will be much easier to you to understand this. Let's increase this. So here the 5 elements are present into the array, so the for loop will iterate 5 times. So for the first iteration, for I equals to 0, so here I will be 0, that is a of 0 is equals to 1. So here the first element you can see a of I, so here you can see 0, so 0 is equals to 1. So if 0 is equals to 1, it will return 1, otherwise it will return minus 1. So 0 is not equals to 1, so it will return minus 1, and minus 1 will be stored into this sum, and this will be added to the previous sum. So now our sum will be, so this sum will be, so previous sum was 0 and now this is minus 1. So 0 plus minus 1, that is minus 1. Okay, now it will check here if mp dot find of sum, that is in this find here will be the key. So now our key value is minus 1. Why? Because here the sum is minus 1. So our key value is minus 1. So we'll check if minus 1 key is present inside the map mp. So you can see here in the map mp no key is present. As there is no key is present inside this map, so we will go to this else condition, and in the else condition I will be stored into the mp of sum. Okay, so here our key will be minus 1, that is we can write it as mp of minus 1 for better understanding. Okay, this is the key, so I will be stored into the mp of minus 1. So our sum value was minus 1, so that will be mp of minus 1 will be created and the I value will be stored. So I value, so this is the value, so the value of I is 0 and this will be stored into the value part of the map. So 0 will be stored here. Now we will increase the I value and I value will be 1. Okay, so as the I value is 1, so here will be a of 1. So a of 1 is equals to 1. So a of 1 is, here you can see a of 1 is 0. So if the 0 is equals to 1, if this is true, then it will return 1, otherwise it will return minus 1. So 0 is not equals to 1, so this will return minus 1, and minus 1 will be stored into this sum and the previous sum will be added. So our previous sum was minus 1, so our new sum will be minus 1 plus minus 1. So our new sum will be minus 1. So this is the minus 1 and this minus 1 will be added to this, that is minus 1. So this will be minus 2. Now we'll check the if condition. mp dot find of sum. So our sum value is -2. So find of -2, that is the -2 key is present inside the map. So here you can see -2 is not present, -1 is present. Okay, so we'll go to the else condition and the I value will store into the mp of sum, that is mp of -2. As our sum is -2, so I will be stored into the mp of -2. So mp of -2 will be created and I will be stored into that key position. Okay, right here mp of -2 and here we'll store the I and our I value was 1. So I will be stored into here. Okay, now we will increase the I value and the I value will be 2. So this will be our step 3. So right here step 3 and I is now 2. So now we'll check if a of I equals to 1. So I value is 2. So if a of 2 equals to 1, so a of 2 is equals to 1. So here you can see a of 2 is 1. Okay, if this 1 is equals to 1, yes, this 1 is equals to 1. So this 1 will be returned and this 1 will be stored into this sum. So our previous sum was -2 and now this 1 will be added. So our new sum will be -2 plus 1. That is -1. Okay, so now we'll check if mp dot find of sum. So now our sum is -1. So find of the -1 into the map mp is present or not. So -1 key is present. So here you can see in our mp -1 is present. If this is present, then we'll go inside of this if condition and here we'll check the maximum between these two. So the maximum of result and I minus mp of sum. Okay, so let's check the maximum. So here our result was 0. So our initial result was 0. So here write here 0 and here will be I minus mp of sum. So I was 2. So 2 minus mp of sum. So our sum is -1. So here you can see our sum is -1. So mp of -1. So here you can see mp of -1 equals to 0. So I minus 0. That is 2 minus 0. So maximum of 0 and 2 is 2. And these 2 will be stored into this result variable. Okay. So our result will be 2. So now our I value will be increased and our I value will be 3. And this will be our step 4. So now our I value is 3. So now we'll check if a of 3 is equals to 1. So a of 3, here you can see this is a of 3 and this is 0. If 0 is equals to 1, so no, 0 is not equals to 1. So it will return -1. So -1 will be stored into this sum and the previous sum will be added. So our previous sum was -1 and it returns -1. So -1 that is -2. Okay. So now we'll check here if mp dot find of -2. So the sum value is -2. So we'll find if -2 is present inside this map. Yes, mp of -2 is present. So now we'll go inside this if condition and we'll check again the maximum of this result and I minus mp of sum. So right here max and then the result and the I minus mp of sum. So our result was, here you can see our result was 2. So now our I is 3. Okay, so 3 minus mp of sum. So our sum is -2. So here you can see -2. So mp of -2. So let's see here mp of -2 is 1. So we'll write here 1. So 3 minus 1. So here we'll write 3 minus 1. Okay, so 3 minus 1 is 2. So our maximum between 2 and 2 is 2 and this will be stored into the result. So our result will be updated and this will be 2. Okay, so else condition will not execute and will increase the I value again and our I value will be 4. and this will be our step 5. So now our I value is 4. Now we'll check if a of I equals to 1, that is a of 4 equals to 1. So let's go to a of 4. So here you can see a of 4 equals to 1. So 1 is equals to 1. Yes, true. So as this is true, it will return 1. So this 1 will be returned to this sum, and the previous sum will be added to this one. So our new sum will be sum equals to, our previous sum was -2, so -2, and now this one will be added, so plus this one, so this will gives -1. So now we'll check here if mp.find of -1 is present inside this map or not. So as our sum is -1, so we'll find -1 inside this map. So if mp of -1 is present, yes, mp of -1 is present here. So now we'll go inside this if condition, and again we'll check the maximum of result and I minus mp of sum. Okay, so let's check the maximum. So the result was, so here you can see our previous result was 2, so right here 2, and now we'll do I minus mp of sum. So our I is now 4 and mp of sum, so here you can see our sum is -1 and mp of sum, so mp of -1, so go to the mp of -1, so mp of -1 is 0, so here will be 4 minus 0, that is 4. So maximum of these 2 and 4 will be 4, so this 4 will be stored into this result. Okay, so result will be 4. So else condition will not execute. Now we'll check if I is less than n. So I becomes 5. So 5 is less than 5. Now 5 is not less than 5. So this for loop will terminate, and finally will return this result. Okay, so this result will be returned, and our final result is 4. So this will be returned, and this will be the output. Okay friends, hope you understand the whole concept and the whole code. Okay, so for better understanding, I have tried to explain you step by step and using an example. Okay, so hope you understand the whole concept of this code. So now we'll run the code. So we have right here the code. So here we have write the has include bit standard C++.h using namespace standard, and then we have write a function that is find max length, and inside this we have first an array and n. In the main function, n is the length of the array and the name of the array is a, and here we have write the function and pass this a and n. So we have write the same thing here, and next we have write an unordered map, and this first is the key and this second int is the value, and the name of the map is mp. So this is the name of the map, unordered map. So rest of the things are same as previous, you can see. So now we'll run the code and let's see. Okay, so friends, here you can see our output is 4. Okay, our expected output was 4 and this is our expected output. Okay friends, this is the perfect output. So let's give some another input here and check it again. So let's give here 0 1 1 1. Okay, so for this our output will be 2 because the maximum subarray is this 0 and 1, and this contains the equal number of 0 and 1, so our output will be 2. Okay, so let's run it again. Okay friends, our output is 2. Okay, this is perfect output. So hope you understand this and enjoyed this whole video, and if you like the way how I explained you the whole concept of this code, then please like the video and share it with your friends, and the most important thing is please subscribe it now and press the bell icon, so whenever I will upload a new video, then you will get the notification immediately. Okay friends, so thank you for watching this video. See you in the next video. Till then, take care.